Okay, so we did threads, then we went to parsing, now we're back to threads. Yeah, it seems I'm meandering here. But is there some common thing you saw between parsing and threads? Something you see in your current assignment? Command objects. Okay. So, by the way, if you go and replay this stuff later with something that's not Office 13, and I've recorded the laser pointer, you can't just use your up arrow, down, back arrow keys to go forward and back. You have to go to next and previous, at least on the previous versions, on the latest version. So there's a drawback if you don't upgrade to Office 13 to using the laser pointer. But I think from previous times I've taught, people have said that they miss the fact that the pointer wasn't recorded. Okay, so the common thing between parsing and threads was command objects. Okay, so and that's why I did them both back to back. I wanted to give you a next assignment. So you know about threads. Why do you have to come back to threads? I mean, you can create threads, you can start off threads. Now what the threads do is up to you. How much can I teach you about that? What do you think I need to tell you more about threads? I've given you this powerful tool. Sorry? When you should use it? So, when do you think you should be using threads? Multiple things at the same time? Okay, and you want to parallelize your program, make it faster? Okay, so that's one thing. So that's about when to use. How about how to use threads? Or something more about how threads work. Is there anything else you might want to know? Is there any? I've given you this powerful tool. Powerful tools in general can hurt. Is there some way you can hurt yourself by having multiple threads? Sorry? So you're doing something concurrently, and the two. So we looked at matrix multiplication last time. That you could have one thread multiplying this row with this column, another thread multiplying this row with another column. They could go in parallel. That's great. That's when to use it. So what kind of danger can arise now in this problem?
Two things relying on the same variable, and it can be changed before the other one has a chance to see it, or it can be changed at the same time while it's trying to rate it more.
So these two threads are accessing some shared variables, as you said, and who knows what's happening. And maybe both threads are going to write to the same variable at the same time. What does that even mean? Maybe one thread is going to write to that variable, another thread is going to read from the variable. Then you better make sure that the second thread. I've used a car analogy a lot in this class. Can you imagine the car analogy with threads? Before the world of multiple threads, you could drive only one car at a time. And as long as they're going in separate lanes, things are fine, right? And that's what happened in your problems. And the problem occurs, and so as long as there are different sets of variables, different resources, so in computer science and even in real life, we call shared things as resources. Okay, this room is a shared resource. Only one of us is teaching at one point here. And the road is a resource. And in a Java-like language, the resources tend to be objects. Okay? So things are fine as long as, one thread is animating one shuttle, another thread is animating another shuttle, no problems. Okay? The trouble arises when you have a shared resource, like a shared lane, and all kind of bad things can happen. Okay? And I shouldn't just tell you how to get the car controls and drive. I have to also tell you the driving rules and when to stop and when not to stop, for instance. Okay. So in our task, as I mentioned, we had our thread example involved animation, and we were animating a shuttle, and we had two threads that animated two different shuttles. And before we get into that, let me just point out one thing which I haven't said formally. So I've got a tree here, basically, right? I have got nodes. Nodes have arrows between them, and essentially, this is the root, and here are the nodes defining this set, and we've got a tree. So this is a special kind of tree. In fact, this is generally a graph. And what are these nodes exactly here? Methods. Okay, methods and the arrows, and an arrow exists between two methods if arrow exists from one method to another method if the first method, the other method. Okay, so we'll just call it a call diagram. And node labels are methods and classes. Okay, type basically. Sometimes if you want to distinguish between multiple implementations of the same interface, we use classes. And this is something I can ask you to draw in an exam, right? I can say, please give me the call diagram for this problem. Okay, so if I ask you that, you know now what a call diagram is. Okay, and now let's look at this call diagram. So in this call diagram, we've got two different shuttles, two different animators, two different commands, two different threads, and because each thread is accessing a separate command, animator, and shuttle, things are fine. This is like driving in different lanes. Okay? And now what would shared lane mean? There's many things we can share here. Would we be sharing, for things to go bad, would we be sharing the same shuttle? If they're different shuttles, we are kind of safe. So we would be sharing the same shuttle. And let's go and share the same animator also. Okay? And so what I've got here now is two threads with two different command objects, which both go and animate the same shuttle. So there's the same animator, which references a single shuttle. Okay? And I now go and say, I start both threads. What's going to happen? If you remember, each animator did the following. It took the shuttle. Shuttle was at a particular position, XY position. It said animate from origin. It could go diagonally. That was a little harder to code. So I went it a simple way. It went up the y-axis, then it went to the across on the x-axis. Okay. So now when I go and start two threads at the same time on the same shuttle with this particular animation shuttle animator, what do you think is going to happen?
Originally one shuttle that was higher than the shuttle, so that you might have your shuttle animation thread 1 calling U to the X direction, shuttle animation thread 2 is calling U up.
Okay, so what's going to happen? So we have two masters controlling this puppet here. So what's the puppet going to do? Ultimately, it'll come back to its position. Okay, that's what both want. But in between, it's going to chaotic. Okay, and it's just going to swap between the positions. Okay, it's going to shake basically. And let's go and see. Two threads accessing the. And here's what I do. I create one shuttle. I create. Okay, so I'm just taking the old code and using only parts of it. And this is what used to happen. Sorry, this is what used to happen. I had two shuttles, two animators, two threads. We knew what happened there. Okay, and now I start doing things that I create one shuttle. Okay, one animator and two animations. Okay, and I just so that I can see things properly, I start off one guy, and then I start off the other guy. Okay, and happens now. And what happens is basically unpredictable. That's the key. Okay? There are two masters, and depending on how the operating system is scheduling these threads, depending on how much time I made it wait, so how do I, is this the one that's, okay. Okay. So, oops, I thought I corrected it. Well, I got the wrong slide here. And I hope I've got the right slide deck. Let me play it one more time. Oh, you saw that, yeah. And the first time you didn't see it, right? Or did you see it? Not only are the threads unpredictable, PowerPoint is unpredictable also. Okay. Good thing I tried a second time. So you saw something. So we have this loop. What do I want? Oh, so that one, okay. So we have this loop being called twice. Okay? We have two threads that call the same method at the same time, essentially. Okay? Each time, and this particular method has got this variable called current y. Okay? Now, each time you go and call a method, its local variables are, that's a local variable. You get a new copy of the local variable. Okay? So this whole stack has got these records in it which contain all the local variables of that particular method. Okay? So if I call the same method 5 times, okay, I get 5 copies of that local variable. Okay, but they're all stacked up on one stack, so things are fine. Now what's happened is I've got 2 stacks on 2 different threads. They both have a call to the same method. They both have a copy of the current y variable, which is a local y variable, which is a local variable. Okay? And they're both trying to go and set the shuttle y to that variable. And current y is one value in one method, another value in another method. Okay, just we go and set the shuttle y to be that method's current y. And we go to sleep. Okay, so that's a natural time for somebody else to now execute. They go and say, okay, I'm at my y to be the current, to be the shuttle y. So my shuttle y is oscillating between these two y's, and that's why we saw the shaking, the oscillation in the. Okay? These are the bad things that can happen when you go and have multiple threads that are stepping on each other's toes, basically. Okay? So, question is, and just in case you don't quite believe what I'm saying, or you want to see this in a concrete way, here's what I did. I put 2 breakpoints in the same method that I say is shared. Okay? And I started both threads, and I made one thread wait at this breakpoint, another thread wait at this breakpoint. And if things are as I told you they are, then I should be able to see one thread stopped here, another thread stopped here. Okay? I can only see one thread stack at one time. So right now I've selected one of these threads, which is this particular thread, and I'm seeing where it is currently stopped. And it's currently stopped here. Okay? Next, I'm going to go and switch to this thread by just going and clicking on this thread. And I will go and see that the next thread is stopped here. Okay? So this is something you can actually see. And that's what I see here. Okay? So that's interference. Now, that's what we get. Should we make this a feature or should we make this a bug? Is this good or is this bad? If it is bad, what really do we want to happen? when we start two threads accessing the same shared resource. Okay? So I'm hinting it's bad. So why is it bad? Well, that maybe you want that effect.
There's other ways to get that effect that don't require you to do this.
There are other ways to get that effect, and we don't even know what that effect is, right? We have no control of the OS. So if we really wanted that, if you're going to do something, it better happen each time. Unless I'm demonstrating something that shouldn't happen. Okay? So that's not what we want. Okay? I mean, we could want that, but that's typically not what we want because we want to make things predictable. If we're going to make things predictable, what would we want to happen if I start two threads accessing the same shuttle? What's some good semantics? So first question is, what do we want? The next question is, how to get it? And what's the simplest thing you can think of?
Threads could run two different methods of the same object.
So they could run two different methods of the same object. Okay. So one goes and moves in the x direction, one moves in the y direction. So I've changed my program in that case. Here I'm saying I really want it to be that particular, that's what the programmer said. So we could change the program to not drive in the same lane, essentially. But supposing they are driving in the same lane for whatever reason. Okay, Fred?
You create a common current Y, like both currents. It looks like on each.
So you could have the two threads somehow know about each other and make the current Y a global variable. Okay, but then if it's a global variable, then both guys are setting it to different values actually. Because in the beginning, what happens is that they go and say, let me go and set current Y to be the origin, and they start incrementing the current Y. So one guy's incremented current Y, and then the next guy comes and makes it to the origin. So things have got even more haphazard. Not only is the shuttle shared, but the Y variable is also shared. So it's actually getting to be even riskier.
You could use some kind of, maybe if there was a function in thread somewhere, and the objective of the other thread was trying to make some people change the same variable.
Excellent. And if it was, do what?
You would sleep until it was.
Okay, excellent idea. Okay. Excellent idea that won't work. Okay, but that's exactly how you should be thinking. So you're saying the both threads will access some global variable that is going to say, is this method locked or not? Right? Essentially. And whichever gets to the method first will go and say, I'm locking the variable. The other thread will, before it starts, go and check the lock variable and say, is this method locked or not? If it is locked, I'm going to go and sleep. For how long should I sleep, by the way? Until the other person. Okay, so that's interesting. Then the other person, when it goes and finishes that, has to go and make this thread unsleep. So sleep is not going to work, but we need something like sleep, which we'll call wait. And something like wake up, which we'll call notify. And that is going to be next time. Okay? But assuming we can do that, can you guys see a problem with having this global flag that you check? Is this method locked or not? James? So if you have multi-core, they both can access that at the same time, Zach? What about non-multi-core? Even in non-multi-core, there can be many a slip. Okay, and one guy can read the value, the other guy can write the value. So basically, I have a problem of shared resource, my shuttle. To solve the problem, I've created another shared resource, the flag. I've got a recursive problem. And I can't solve one problem by just creating another version of that problem. Okay, so this is called busy waiting. And as it turns out, for multi-core, the solution is very is different from single core. But we really, as programmers, cannot solve this problem. Unless we go and program the threads, we just can't solve this problem. We need something from thread support, and thread support is just my library that goes and accesses the OS library. And so we need some help from Java, the OS. Okay? And here you and you're on the right track. You said, let's assume there's a wait and a notify. Okay? Now, wait and notify makes sense. That can be done, but that puts more work on the programmer. The programmer now has to go and say at the end of a method, please notify. It has to keep track of who's waiting and notify them. Okay, so can we think of some simpler rule that we can get from Java? Rather than going and asking Java to give me a wait and notify, which it does actually. Can I ask you to give me something more simple where I just want to run my car and I don't want to know about the other cars. I just want to make sure that, and what you wanted was basically these guys to be executed serially, right? You wanted one animation to happen, then the other animation to happen. If those are the semantics we want, can I think of some simpler semantics, simpler construct from Java than this wait and notify, which is actually much more complex?
You could make like an is in use boolean that is true in the beginning of like before it's editing something that becomes false again when it's done.
So that was Keenan's idea, that you have a Boolean that locks that method. But that Boolean has to be shared by all the threads. So there's a shared resource, and one guy can read it, the other guy can write it, and they both see.
What if it's a read-only?
If it's a read-only variable,
They have like an instance of each other and you're told that it was true and not.
if it's read-only, then I can't write it, right? I can't go and say I've locked it.
You can just pick whatever method sets like both X and Y synchronized.
So you can go and say something to the method. You can tell Java, whatever method is I'm here, please execute it. Please make it synchronized. What does that really mean? So you're basically saying, if a method becomes synchronized, okay, so what's the solution? What do we want? And how should we? And we're going to do exactly, sorry, you had to remind me your name again. You told me yesterday and I've forgotten. I'm sorry. Andrew. So what Andrew suggested, that we will go and just put a label on the method. Tell Java, here's my intention. I would like some synchronization on this method. Okay, that's what it's basically saying intuitively. And please do whatever it means to synchronize this. Okay, so and that would mean, as was suggested, that only one thread can execute a synchronized method at a particular time. Java just makes sure. Java internally will go and keep a, yeah, James?
What are you trying to synchronize with? Where are you?
So I'm saying I'm a synchronized method. That means I know I'm a method. I'm a method that can be called by multiple threads. I'm an object, right? And I'm the thing you execute, and thread is what is the actor. So I'm just saying that I have a synchronized method. So if one, and all the stuff that you guys are talking about, having a flag, basically Java internally will keep a flag. Okay? And it will make sure that flag cannot be changed by two threads at the same time. It just can do that. Okay? So it's going to internally keep a flag and say, is this method occupied or is it not occupied? If it's occupied, and another thread goes and knocks and says, I want to execute on this method, it says, you wait in a queue. Wait till this method finishes. That means Java knows when a method finishes execution. So you don't have to go and say notify before you end. Java just knows that you've finished. And it goes and says, okay, you've left the room. Let me go and see who's waiting outside and let them in now, the next person. So we will execute these methods atomically. Okay? Atomically means that only one thread will execute the method at one time. Okay? So that's what I'm saying here, and that's atomic method execution. And basically, when a method is locked by a thread, it's not as if the other thread just goes away and has to die or something. It just goes and waits in a queue, and the next thread next thread will execute. Okay, guys, understand what synchronized means? It's a very easy thing to do. I just go and label the method synchronized, and all the magic happens in Java. You just have to understand what Java is doing. Using it is not difficult. Right?
So does this get around the problem of blocking that we thought might just like storing thread calls in the queue? How does that really solve the problem?
So what's going to happen now based on this? Let's go and see if it works. Okay, let's go and see. So what do you think is going to happen now? I started 2 threads. I made that method synchronized. What's going to happen? Zach?
It's going to animate it once, then again.
It's going to animate it once. It's going to animate it a second time. Okay? Or it should. Okay? So do you understand why, Fred?
Yeah.
Okay? Basically, when the second guy came to the synchronized method, it just blocked. If you go to the debugger, you will see the second guy is just blocked at entry. And as soon as the first guy finishes, the second guy makes progress.
So, but which thread, which thread gets her first is still random, right?
So I was a little careful. I started one thread. I waited a few seconds so that it could get into the thing. So I knew it was a little bit more predictable. But otherwise, it's not random. It's up to the OS.
Right.
There's a term called random, and there's a term called non-deterministic.
Right.
Non-deterministic is that you can't guess what's going to be. Random means you generate a random number.
Okay.
Okay.
But like, what's the time when we want that to happen?
What's the
When would we want 2 threads competing when we don't determine which one will get first?
so the question is which one should so can we have rules as to which one goes first? If we really want rules, then we will start our threads in a certain order. When we go and start 2 things at the same time, okay, it's like saying we can all decide, I'm going to start my commute at 9:01, you're going to start my commute at 9:02, 9:03, and then we won't get into trouble. But that's so hard to do, right? That because you have so much awareness. So what we'll do is say, you know what, we'll just start all our commutes at the same time, and then whoever reaches first gets at the stop sign, and they go. And this is a rule that Java will enforce. So it's okay if I go first or you go second, because our program doesn't depend on that. It's okay if my first row and first column here got multiplied before the second row and the second column there. Okay? It'll all be fine in the end. So we really don't care. If we really cared, we have to wait for Tuesday's lecture. And the thing is, this is simple. When you use something simple, you get some simple semantics. You want to change things, you got to work harder. Do you have this?
Yeah, well, I'm still thinking that you could use flag, but you could, instead of having it like global, you could just have it for each thread, and maybe have like a boolean for each thread, and then have a condition.
Okay. So, firstly, isn't this easier than your solution? I just labeled the method synchronized. I didn't have to create a boolean, I didn't have to do a check, I didn't have to do a notify. Right? This is certainly easier. Now, the variable can either be global, and it's not as if the variable is kept in a thread. The variable has to be in some global object. Okay? So you really can't make something local to a thread, because thread doesn't have variable in it. Thread is something that executes the stack. So you're saying somehow make sure that one thread cannot access a variable of another thread, and we can try to come up with rules of that kind. If that is the case, then how can the 2 threads cooperate? For them to cooperate, they have to look at the same variable. Okay? And just Google, I recommend you do OS course, but just Google for busy waiting solution. Okay? And you'll come up with, maybe I should have really had some slides here on that. But the point is that you just intuitively, you cannot, like I said, solve a shared resource problem by having another shared resource. That's the intuition I want to give you at this point. Okay?
I was wondering what would happen if you had like different animations, like if you wanted like to move side to
So if you really want to side, you better program that in one loop. Otherwise, it's just, or you use this wait and notify that I'll talk about. Okay, it can be done that way also. So what did I do? I put a lock on this method. Now I've got this locking capability. I can put synchronize anywhere. And the question is, where should I put it? So I put it here. It seemed to work, at least in the demo. Here.
That would cause a shutter effect. Because what would be okay for thread 1 to call set X, well, thread 2 to call set Y.
So it doesn't solve the problem, right? We want that loop to be executed atomically. We want set shuttle X and Y to also be executed atomically. Okay? But we definitely want the loop to be executed atomically. Otherwise, they interfere. So I couldn't have, it's not enough to do this. Okay? It's probably a good idea to do this also, in case you come to the shuttle from different animators. Okay? But that's not going to solve that problem. Okay? Questions? Okay. What if I put the locks here?
Those are only being called by one object, so it doesn't make sense.
They're being, say that again?
There's only one thing calling each one of those one methods, so you can't exactly synchronize one thing with itself.
So by synchronizing two things, you're just not solving the problem because there's this one thing that's common, right? So this really means that my run method is in this object. This run method is in another object. They have different locks. They have different queues.
Yeah.
So they are not being united by any one common. There's no common guard here. Okay, it's like I've got two different roads that are leading to a common road, and I've put the barricades on those roads. Okay, so that's not going to solve my problem. Each command has its own queue. Okay, each command object has its own queue. So that's not going to solve the problem.
So generally, you lock the highest share resource.
You lock the most appropriate resource. Okay, and in this case, it happens to be this resource. And what I want to say is that if you lock, but the point I'm trying to make here is, if you lock this method, you get locking at a smaller grain than I want. That's the point I want to make. When you lock here, you get the bigger grain. When you lock here, you've got two different objects, and two different objects are two different queues. That's the point I want to make. Okay? As long as you understand semantics, then you'll figure out what to do in any problem. Okay? What if I go and lock the thread creation? Okay, and I'll just show you what that means. I go and make my concurrent demo shuttle, which is going to create my thread and start it. I go and make that a synchronized method. Is that?
Because you just have the main thread, which is a singular thread called.
So the main thread calls it. The thread creation is atomic. Then the main method will call this thing again before the first thread is finished. Remember, this call is asynchronous. Okay, somebody asked on Piazza also, what's asynchronous? This call, you're essentially calling animate from origin. I seem to have an old version of this. This should really be a command object. So you're actually creating a thread here, and this is asynchronous because you're not waiting for the thread to finish. So both threads, each thread creation is atomic, but once they're created, they can interfere with each other. And by the time you finish this method, the thread you have created has not finished. That's the point I'm trying to make. Okay? There's a mistake here. This is not quite the one that was the final one we came up with. Okay? Questions? Thread is not locked. A method is locked. When a method is locked, think of this room being an object. Think of the professors coming in being the threads. Okay? So they don't have global variables. I can go and put something on the chalkboard here, and that's a global variable. Okay? And when I lock the room, then no other thread can come in while I'm here. Okay? That's locking an object or a method. Okay? That I've locked that particular door and nobody else can come till I go and open it and then the next person comes. Okay? Did I answer your question? Okay, let's make things even more fun now. What if I have two synchronized methods in my animator? Okay, and I actually do. One takes OE_frame as an argument and calls OE_frame.refresh. That is to allow anybody who doesn't know about property notifications to be able to use animation. One doesn't take OE_frame as an argument and just relies on the plotted shuttle announcing events. Okay, so what if my what I have two of these methods? Based on what we've learned, can we have a shaking shuttle? Okay, James?
The two, and the two animate origins are different.
They're different methods. They're both synchronized. What if they both get the same plotted shuttle as an argument? Zach? As it turns out, we don't know, this animator doesn't know, and I could have gone and created the same window for them. I could create the same window, I could have done this. We don't know what the main method did. Let's say we are bad, okay? So we go and create the same window and same animation. Keenan?
They probably would be messed up because it's not locking that. I mean, that one method is locked, and you can still also show the other method.
So you're saying we'll get shaking? Somebody who knows about threads, who knows about synchronized methods? Andy? What's going to happen? What's going to happen when you have two synchronized methods in the same object? What could be a different semantics from what I've told you? I've told you one semantics that was not quite the semantics as it turns out. So think of each door here being a method. What I wrote here is the global variable. Does it make sense for me to lock one door and not the other? What are we really worrying about? Global memory, right? Where is memory kept? In a variable. We are really locking the instance variables of an object. That's what we really want locked. So when you go and say synchronized on two methods in the same class, you're saying, based on what I've hinted, if a method can execute, a thread can execute a synchronized method in an object if that method only, or no other synchronized method is being called in that object by a thread. If I have locked, if I lock all the synchronized doors, then you can't get through any of those doors while somebody's in there. Okay? So those are the right semantics, not what I told you earlier. And the intuition is, in this example it works, but the intuition is that we are locking the variables, the data in an object, and that's why, yeah.
You would still be able to call non-synchronized methods.
You would still be able to call non-synchronized methods. So does it make sense to have an object in which some methods are synchronized and some are not synchronized? Why not just go and say public synchronized class, which basically means synchronize all the methods. Yeah, Zach?
You could have read-only.
You could have read-only methods. Okay? So I lock the doors so nobody else can enter here, but I allow the windows to be unshuttered so people can see what's happening. Okay? If we had windows. And so that's the intuition. That you could just have a public synchronized class, which means you lock everything. That's way too much. So then instead what you have is a bunch of synchronized methods and a bunch of non-synchronized methods. And the non-synchronized methods could be just the watching methods that's saying what activity is occurring here. The synchronized methods will be the ones that are actually changing the activity. And we don't want that to happen. Okay?
So to clarify, you always want all of the doors to be locked
all of the doors and all the windows. And the door is a synchronized method. A window is a non-synchronized method.
Because you can come in the door and erase each other.
Yeah, you can come into the door and create havoc. And through the window, you can just peek. So you can come in through the door and change what was happening. So that's think of that the doors are synchronized methods of yeah, that's kind of what it is. If you don't make it synchronized, then you have open doors.
But you never have a situation in which, or like you shouldn't have a situation in which some doors are locked and some doors are open.
So you shouldn't have a situation in which some write methods are synchronized and some write methods are not synchronized. That's the way to put it. Okay.
If there are multiple objects, would it be possible while one is calling the first method there for the second one to call the second method? Or if one is locked, would both be locked to some extent?
You're saying you have two objects.
Yeah.
They both are synchronized methods. So you're creating headaches for me, right? One object with synchronized methods I can understand. Now two objects with synchronized methods, now you're creating headaches. Okay, and you're creating good headaches, exactly the headaches you should be creating. So what are you worrying about? That you have a synchronized method in one object, you have a synchronized method in another object, and what's the exact danger you're worried about?
If one method is being called in one object, the other one being called in the other.
Oh, okay, that's true. That's no problem. I have two different objects, synchronized methods here, synchronized methods here, two different rooms, two different rules. I thought you were getting into something more complicated.
I meant if the asynchronous shuttle animator were being interacted with from two different objects.
Okay, so from two different threads is the issue. Okay, so two threads will come in here, and if one thread is executing this method, no other thread can execute this method or another method. Those are the rules. And if you have a separate object, you have a separate queue, and we don't even worry about that. So then that's not a headachy question. Is there any headachy question you guys have? If you don't have, I'm not going to answer it. But if you have, I will try to answer. There is a can of worms that can happen. Yeah, what's the question?
What is the headache question you want us to ask?
No, I don't want you to ask it. But if you have one, I'll try to answer it for you. I want to cover some material too. But it's,
You have two threads and they end up like getting locked against each other.
they get locked against each other. Okay, so I have entered this room, and I have a chalk. And there's a classroom next door that has a duster. Sorry, I'm using old terminology here. And I need to go to that room to get the duster, but that room is locked. But that guy can't make progress till he gets a chalk from me. So he has to come into my room. So I can't go into his room, he can't come into my room, and we have a deadlock situation. And in the cars analogy, we have what? A gridlock. Okay? And that is, you asked me, should you always put synchronized methods? I said yes. But the danger is that you can come up with deadlock situations. Sometimes you just say, the deadlock is so hard, I won't make anything synchronized, and I'll just pray that nothing bad happens. At least my demo will work. Okay? So that's sometimes synchronized methods can cause that kind of issue. Yeah.
If you get into a deadlock situation, does Java throw an exception?
So there's, Java has to firstly detect it. That's not easy, like the halting problem. Okay? But there are deadlock detection schemes when you are more organized, and there are deadlock prevention schemes, and all of that stuff is good stuff for COM 530. Okay? But that's the kind of problem that can occur. Okay? Questions? So only one synchronized method can be executed at one time in an instance of a class. Sorry, not in a class, in an instance of a class. Okay? And lock and queue are with the object, not method. So start call to synchronized method in object O. If some synchronized method is executing in O, then make calling threads wait in O's queue. That's the semantics. Okay? So when you start the call, you do a check. This flag we are talking about that's kept by the OS, not by the user, and you'll make the guy wait in the queue. And whenever the call to a synchronized method is finished, you unblock the first waiting thread in O's queue. Okay? So it's with the object if the method is not static. If the method is static, it's kept with the class. Okay? The queue is kept with the class. And the analogy for this is that, we're just going to have stop signs, and this is a shared resource, and only one car will be at the intersection at any one time, And that's the analogy for synchronized methods. Okay? No matter which door, which end you come up with, you can think of all of them as being different methods. There is only one queue, and you cannot access the shared resource concurrently. Okay? Questions? Okay. And just to make things complicated, to show that life is not that easy, what if I had two shuttle animators that access the same shuttle? Okay. We were very conveniently using only one shuttle. You know, an animator here, an animator here, and accessing the same shuttle. I can make this synchronized, but that will not synchronize the loops. And if you really want multiple animators to be synchronized, our synchronized method will not work. We need something more fancy. Okay? So I just want to show you the limitations also, that the synchronized method is a form of synchronization that is built in, but we need our own synchronization protocol, and for that we need to learn some more. Okay?